Hello, I'm JW. Today we have some cable to look at, and this is the cable here. It's actually a lead covered cable, despite it looking very much like the plastic covered twin and earth stuff that you can buy these days. And so this was actually sent in, and it came with the cable that we saw in the previous video where we set on fire those bits of rubber covered stuff and various others. So a closer look at this one. So here is the lead covered cable, and this is entirely covered with the metal lead on the outside. And as you see, it stays in shape extremely easily. It's very soft just to bend into the shapes that you would want, and it holds the shape extremely well. Now this is not going to be obviously a metric size because it's very old. Lead covered cable hasn't been used since basically the 1940s and earlier, so again, if any of this is still installed, massively past its replacement date. Now in terms of actual physical size, on the outside here, see, it does appear in a similar form to the more modern twin and earth, and that's what we've got here. This is a piece of the plastic twin and earth you can buy today. And you see, these two are pretty much the same sort of physical dimension there, but this is actually a 2.5 square millimetre. It's got the two cores and the earth in the centre, but this stuff is considerably smaller. And have a look at the other end. I've just stripped a section off here. So here's what's inside. We've got two cores, and got red and white as the colour, although the white is more sort of a off-white, sort of yellowy type shade, but red and white as the two inner cores. And to the inner side conductor is a single strand. Again, this will be tin copper, as was common with cables of the time. But this is actually considerably smaller, because here's our piece of 2.5mm twin and earth, but the actual cores are more akin to this one, which is only 1 square millimetre, and you see they match up pretty well in size. So although the conductors are only 1 square millimetre, the outer covering of course is considerably larger, this insulation here being considerably bigger than on the modern equivalent that we've got here. So there's a lot of weight and materials in this cable, and of course this would have made it a fairly expensive option. Possibly one reason why it was discontinued from use, because all this lead on the outside, of course, being a fairly expensive choice. Now this is the modern one with the earth in the centre, and of course there's no earth in the middle here. Of course you could use the outer covering as the earth connection on that if required. But again, bearing in mind in the 1940s, putting earth on things like, say, lighting circuits was not a big priority. So again, it may not have been an earth type of system. Now the cores here we've got are going to be the rubber insulated with that cotton braid over covering, similar to what we saw in the previous video when we set some of this on fire. And slightly odd choices there of the red and the white, and again that was probably what you had at the time. Now in terms of the weight of this stuff, it's very difficult to obviously convey. If you actually pick it up, it feels very heavy there. So what I've got here are 3 pieces of cable. Here's our lead covered stuff we just saw there. This is some modern twin and earth in the 1 square millimetre variety, and that's sort of electrically equivalent similar to that in terms of the conductor sizes. But as you see, it's quite a lot thinner in actual outer dimensions. And then this is some 2.5 square metre twin and earth, and although that's bigger inside, it's sort of dimensionally equivalent to the lead covered stuff, or certainly as near as we can get. So first of all, let's see how much the lead piece here actually weighs. So just that small piece coming in at 16 grams, and if we compare that to the electrical equivalent, the 1 square millimetre, that's only coming in at 4, so basically this is around 4 times heavier than its electrical equivalent in plastic. And then even with the 2.5 square millimetre here, let's see the weight of that one, and that's coming in around 8. So even though that's dimensionally almost equivalent, it's still half the weight of the lead here. So as we saw there, it's coming in around 16 grams. Now here's the piece I've just removed here. So this is just the outer covering, which of course was over those conductors. Now in terms of stripping this, all I've done is basically take a knife here, score around the outside there, and then basically just break off this piece, which then just pulled off quite easily. Whether that was the approved method back in the day isn't clear, because say this stuff hasn't been installed for sort of 70 odd years. So of course information about how this is installed tend to be lost or forgotten. But nevertheless, it does come off quite easily. Once you've just scored it, it just breaks away and then just pulls off there easily. And this is of course quite a soft metal, so take this just steel blade here, so you can dig into it quite easily there. And so we can also just scratch up the surface of that. So quite a soft and fairly malleable metal there. And again, if we just bend it there, see it does bend and will eventually break, tear open quite easily. So not terribly difficult to really work with, although of course its huge disadvantage are the massive cost of this stuff, because lead being a fairly expensive metal, and there's a lot of it even in this short piece. Here's a closer look at the piece I removed from the outer, and you see it's quite a thick actual covering there, so it's quite a lot of substantial material in this, but as you can see it's still quite a soft and easily formed metal there. So sort of grey on the outside and this sort of more shiny where it's also been recently cut apart. But yeah, certainly not as bad as you would imagine to actually form, and say this does bend pretty easily into whatever shape you want. So look there at some lead covered cable, something which hasn't really been used since the 1940s and earlier. So of course if anything is still installed, it's well over 70 years old and quite frankly should have been replaced before. And as with the previous video, we saw that rubber insulated cable. The problem with this is not the lead covering itself, because that belief's going to last forever. It's the inner cores there, which you can see in the red and white there, which are that sort of rubber insulation with the cotton overbraid. And the rubber part, say, dries out over time and turns to crumbly dust. So wherever it's connected to anything, you'll find that it's just disintegrating, leaving live conductors exposed. And once that's happened, you can't fix it at all. It's just a question of replacing the whole lot. Because if you try and start cutting back, you'll find that it just crumbles more and more and more until you end up with nothing actually left to connect to whatever you're fixing it onto. So let's say lead covered cable there, not particularly common these days, but nevertheless it does still exist. And in case you're wondering, yes, lead is a toxic metal, so of course you wouldn't want to be taking some of this and eating it. However, just handling it in your fingers is not a particularly risky activity, unless you're going to start sort of handling food and then consuming the lead, which obviously you're not going to do. Clearly you're going to wash all that off in just a moment. So until next time, thanks for watching.